Clarkson unknown model, late 1930s. This is the documentation of the experience of a hobby project, made with the hope that it could be helpful to others. However, these videos are not intended as tutorials, they only show the development of a personal practice, which may or may not be a good one. Therefore, if you are following along, you are doing so at your own risk. To put things in the proper context, it is a good idea to start from reading this annotation, appearing on radiomuseum.org, regarding the brand Clarkson Paris. The unit of this restoration is believed to have been made in the late 1930s, therefore, it is relevant only the first paragraph. It says, there was a company called Radio Clarkson, located at 70 Rue de l'Aqueduc in Paris, owned by Mr. Clechy, which was placed under provisional administration by the General Commissariat for Jewish Affairs on May 14, 1943. The logo of the brand that is commonly seen on the Internet is slightly different from the one appearing on the cabinet of the unit of this restoration. The style of it, together with the technology of the coils and the style of the dial mechanism, reinforces the thesis that the unit could have been made in the late 1930s. Unfortunately, there is no more information about this radio model because the back panel where it could have been written is missing. The chassis has a number also written in pencil on the side. The reason is unknown, but it seems remarkable nonetheless. The unit arrived in fairly good condition, except for the metal speaker grille, which lost one of the 3 bars. But the knobs on the front turn and operate correctly, which is encouraging. Some Vaseline oil is put on the knob screws before trying to release them. The chassis is held to the cabinet wood only by 2 screws, which are removed. The chassis is extracted and the loudspeaker is disconnected. Also, the speaker is removed from the cabinet. Initially, the plan is to extract it together with its panel, but 2 screws of the panel are hidden under the basket. Therefore, it is necessary to extract the speaker separately. The speaker cone is like new, and it is absolutely necessary to preserve it with a cardboard protection until it will be put back in its cabinet. This is a first look above and under the chassis. It is clearly visible that the unit was serviced before replacing all the capacitors. But most importantly, the wiring was arranged beautifully by the factory, and that was not disturbed by those who serviced the radio. The radio may well be still operational, but it is not tested yet. The dial glass is removed. There are only two screws keeping it in place, but also the pilot light sockets on top must be removed for the purpose. The band indicator is separated from the switch shaft and later also from the dial panel. Before separating the dial panel from the chassis, all the tubes are removed and laid in a safe place. The dial panel is held to the chassis only by two nuts, but accessing them is difficult due to the presence of very delicate coils. The two washers are different, suggesting that the dial panel was already removed when the radio was previously serviced. All the remaining parts still attached to the dial panel are separated from it. The dial mechanism is connected to the variable capacitor shaft by an elastic coupling consisting of a special rubber disc. This disc is now too old and brittle. Therefore, something else that should be compatible is fabricated using the rubber of a bicycle inner tube. For reference, these are the measurements of the original rubber joint. The variable capacitor grommets are significantly deteriorated and cannot be revived by just applying oil. However, the variable capacitor is installed on top of the delicate antenna coils for the medium and long wave bands. Therefore, in order to replace the old grommets, it is necessary to move aside this important coil. This and the other RF coils are held together by a threaded rod made of a type of resin that can be confused with nylon, but which is actually something more rigid and fragile. The new grommets have the same diameter of the old ones, but they are not as soft as the original ones were. However, they will work. Once the first two grommets have been replaced, it is necessary to put the antenna coils back in their original place in order to access the third and last grommet. The nut used to connect the threaded rod of the coils is only finger tightened for fear of breaking the rod. The upper surface of the chassis has corrosion dots everywhere. It is still visible a thin layer of zinc paint that after so many years is not able any more to protect the iron underneath. Ideally, all the components should be removed, leaving a bare chassis which could be submerged into an acid solution for removing completely the rust, allowing then a proper treatment with new zinc paint. But this is not the case in this particular project, where preserving the original wiring is also very important. Therefore, an attempt is made using some DIY gel rust remover. However, while it is usually fairly effective, these corrosion dots do not get dissolved easily, and it is necessary to also use balls of steel wool. It all becomes very messy, and the steel wool removes also the residues of the original zinc paint. After cleaning everything from the rust remover residues using various products, including alcohol for the most sensitive or delicate parts, it is necessary to repaint the chassis. Some drops of acetone are sufficient for removing the unwanted residues of paint. The unit was already serviced before, probably more than once, and all the capacitors, except for one, were already replaced. However, while doing a major restoration process, it is advisable to reconsider the condition and the ratings of the components that were used. It is a personal preference to use higher voltage ratings for the replacement capacitors, as well as adding insulating sleeves to the connection wires. Therefore, for one reason or another, including changing a few values, under the circumstances all the capacitors are replaced again, while the resistors are all kept as they are, even though they are all high at the limit of their tolerance. The IF transformers are inspected starting from the first one. In these transformers, the primary winding is on top. After some general cleaning, using alcohol, also some drops of acetone are used on the trimmers. Originally, the nuts used for adjusting the trimmers were isolated from the blades, allowing to use metal tools for their adjustments without fear of making shorts. However, now there is some electrical leakage, probably due to dirt or to the products used for cleaning them. It seems safer to prepare a piece of plastic for insulating the trimmers from the metal shield. Once all is done, the shield is put back on the IEF transformer and fixed on the chassis. Then the same is done for the second IEF transformer, but that does not appear in these clips. When it is possible to do some testing on the radio, the first thing that is verified is the local oscillator, loosely coupling the oscilloscope probe to the oscillator plate in the oscillator mixer tube. The resulting signal is so low that it is necessary to use an old analog oscilloscope that has a preamplifier stage for being able to correctly see what is going on. This is the medium wave band starting with the highest frequency. Initially, the oscillation is distorted, but while reducing the frequency, the oscillation seems to double, due to a shifted parasitic oscillation, which tends to disappear at the lowest frequency end of the band. The long wave band is even more problematic because of the worse quality of the oscillation, and because the oscillation just disappears in the lowest part of the band. Suspecting that there could have been a different oscillator mixer tube in the original design, off-camera a test is made replacing the 6E8 tube with the Type 6A8, obtaining a similar bad result, but with even lower signal amplitude. Observing the typical configuration for a tube Type 6E8, it is noticed that on this unit, the connection of oscillator grid and plate were inverted. Luckily, connecting them in the way that they are supposed to be, the distortion in the oscillation disappears almost completely, although in the long wave band the oscillation continues to disappear in the lowest side of the band. Anyway, the amplitude in all bands, including the short wave that was already working, is significantly improved. Later, also the values for the capacitors C14 and C13 are corrected for obtaining a slightly better result. The schematic diagram for this unit has been reverse engineered. Considering that the unit was serviced, Possibly a few times there remains a doubt about the oscillator mixer tube, which could have been a different one in the original design. In fact, the tube type 6E8 was incorrectly connected to the oscillator coils. It is also possible that in the original design there was no capacitor C16 decoupling the antenna coils from DC currents. On the chassis there was a recent annotation suggesting that the rectifier tube could have been also a 5Z4, but that does not seem to be right considering the particular 5-volt secondary winding of the power transformer, which is better compatible with a 5Y3 actually found on the unit when it arrived. In the RF section of this electrical arrangement, one should notice that there is only the possibility to adjust the minimum oscillator frequency, and only for the medium and long wave bands. Then there are only the trimmers on the variable capacitor useful for adjusting the alignment of one single band of choice in the upper side of it. During this restoration there have been a few amendments. In the power supply area, the external electrical ground has been connected to the chassis. 2 fuses have been added. A halogen light bulb has been put in series with the B+ line for preventing major damages in case of a short possibly generated by a component failure. The value of the filter capacitors has been slightly increased. A resistor has been put in series with the filament power supply line for keeping the voltage provided to the heaters to a safe level. In parallel with the detection diodes of the tube type 6Q7, a germanium diode has been added for making sure that the detection will always work. The resistors R11 and R8 have been replaced with safer values. The corresponding resistors found were not original, and their values were too low. Moreover, the cathode resistor that serves simultaneously the tube types 6K7 and 6E8 has been slightly reduced, adding a resistor in parallel to the existing one for improving the gain. The capacitor C20 was added close to the primary winding of the first IF transformer for filtering out any RF signal from the B+ line. The values for the capacitors C13 and C14 have been adjusted to get a better oscillator performance. The capacitor C21 was added in series to the trimmer C19 to increase slightly the lower side of the medium wave band. For better protecting the antenna coils, a gas discharge tube of 70 volts has been added, shorting unwanted DC charges on the antenna. The chosen IF resonant frequency is 455 kHz, which seemed to fit well the fixed alignment between oscillator and antenna coils. In the audio section, the capacitors C6 and C9 have had their values increased for allowing more bass to the output, while C4 has been slightly reduced with the same purpose, but increasing the voltage ratings because in that position it is usually subjected to greater stress. The input voltage selector, sitting on top of the power transformer, is inspected with the intention of avoiding the possibility to select any voltage below 220 volts. One must make sure that the wire pairs that are detached from the voltage selector remain well connected together, otherwise the primary winding could become open. All the detached ends are insulated, annotating the voltage that they were made for. The input voltage selector is put back at its place. However, later it will be inspected again for removing also the option for 220 volts, leaving active exclusively the 240 volts input. As already described in the section dedicated to the schematic diagram, to the antenna input is added a gas discharge tube for shorting to ground possible excessive electric charges accumulated on the antenna. With the occasion, a small tag strip is added so that the capacitor responsible for isolating the antenna coils has a place to rest neatly. Also, the value of this capacitor is increased compared to what was found from one of the previous repairs or restorations. The signal diodes contained inside tubes can lose their effectiveness over time, and that is one of the reasons why in this radio model the two diodes contained in the 6Q7 are in parallel. To avoid a possible future need of replacing this tube, if at least the tried section is still working decently, a germanium diode in parallel with those that are already in the tube will make sure that the detection will continue working. The unit was serviced probably more than once. The most recent component is probably the filter capacitor can that was made by Radiophil.com, which according to the Wayback Machine at archive.org was active between 2004 and 2011 only. This component seems to be working correctly, but while doing a major restoration, it seems a good idea to change it with new components, also considering the small size of this previous replacement. Therefore, an old and larger electrolytic capacitor can with the same type of mounting screws opened, emptied from its original stuff, cleaned and restuffed with new capacitors. It is a personal habit to put a halogen light bulb in series with the B+ line for preventing major damages in case of shorts caused by component failures or just by personal mistakes. This is a conspicuous modification that may not be tolerated by other restorers, but this precaution saved some of these units, and it is applied also in this case, although trying to keep the original neat wiring arrangement. This radio model has a fusible wire hidden in the input voltage selector. However, that wire is not an accurate fuse, and its purpose may be mostly to prevent fire accidents instead of preserving the radio. Therefore, two fuse holders are installed in these clips, starting from soldering two brass standoffs on the chassis. 2 fuses are installed, one for each power line, because this radio will be used in an environment with non-polarized power plugs, and it will not be possible to predict which one is the hot line and which one is instead neutral. This unit is not going to have the usual array of halogen light bulbs connected in series before the primary winding of the power transformer. Therefore, slow blow fuses must be chosen. After the fuse holders, also a new power cord that includes a ground wire is installed, using extra grommets to lock the cord in place. The connection to the external ground is the most important safety improvement of this restoration. Nevertheless, later, under the fuse holders are inserted 3 insulation sheets of plastic for avoiding the possibility of a short between chassis and fuse terminals in case they lost their insulation. Even though the radio is powered at 230 volts AC, while the power transformer is set for 240 volts, the heater voltage is slightly higher than 6.3 volts. To preserve the life of the tubes, the heater voltage is reduced putting a resistor in series with a very low value, 0.2 ohms. The chassis is prepared with the tubes for proceeding with an alignment. It is not known what was the original IF frequency chosen by the factory. However, it seems that 455 kHz may suit well the alignment between the oscillator and the antenna sections. The signal generator is set for 455 kHz non-modulated. It is connected to the antenna input using a dummy antenna. The signal amplitude is kept as low as possible, as long as it is enough for getting a detection. The oscilloscope is set for reading DC voltage and connected to the pickup input, which corresponds also to the lowest impedance side of the AGC line. The top of the IF transformers are insulated using 2 pieces of plastic that would avoid the contact between the tool and the metal kin. This may be unnecessary, but it is easy to prepare. The band selector is set to medium wave, and the variable capacitor rotor blades are slightly open. While looking at the oscilloscope, the IF transformers are tuned for getting the lowest voltage reading on the screen. For verifying the alignment, the signal generator is set for sweeping between 450 and 460 kHz, while on the oscilloscope the shape of the bell curve can be observed. The bell curve appears upside down because the maximum signal corresponds to the lowest voltage collected by the probe. After the IF alignment is satisfactory, there is very little to do for the RF section. There are only 2 trimmers for adjusting the lowest part of the long and medium wave bands in the oscillator section. Consequently, this is done with the variable capacitor fully closed. Then, only for the medium wave band, the variable capacitor is set for a position close to the highest side of the band, tuning to a station or to a signal provided by the signal generator, and the 2 trimmers on top should be adjusted for getting the maximum signal output. For aligning the oscillator trimmers, it is convenient to loosely couple the oscilloscope to the oscillator plate so that the oscillator frequency can be read on the piece of equipment. As for the long wave band, on this unit it has been necessary to tune the trimmer for obtaining the oscillation with the highest amplitude, excepting that the oscillator starts oscillating only when the variable capacitor is already half open. Observing the oscilloscope and subtracting 455 kHz from the oscillator frequency, it is possible to determine that theoretically the radio could receive the following intervals: long wave band between 95 and 555 kHz, medium wave band between 525 and 1745 kHz. Short wave band between 5.4 and 15.3 MHz. A last detailed view above and under the chassis. Just to be sure, the output transformer impedance is verified at 1 kHz, but without energizing the field coil. The result is comforting because that is perfectly compatible with the output tube type 6 of 6. The dial glass of this unit was made by Impressions Ravex, as it is clearly readable at the top border. The glass is 122 millimeters large, 125 millimeters tall, and 3.5 millimeters thick. The printed scale is still in good condition, therefore it is scanned, but it is not necessary to make a reproduction. However, some very careful cleaning is in order without touching the writings. The dial panel holding the dial mechanism has been cleaned, and now it is connected to the new rubber disc that makes the elastic coupling. The whole mechanism is then connected to the variable capacitor shaft. Under the chassis, the dial panel must be fixed using 2 washers and 2 nuts. This is easier said than done because of the unfortunate location right under the RF coils. Locking the dial mechanism to the variable capacitor shaft, it becomes apparent that the rubber disc is also flexed horizontally, and because of that it might come loose. By cutting in half a couple of very small rubber grommets, the rubber disc is held to the 4 hooks with better strength. The sockets for the 2 pilot lights are installed on top of the dial panel. The band indicator is installed on the dial panel. Its position will be adjusted later when also the dial glass will be in place. The dial glass was held on the dial panel with two pieces of rubber that have turned into pebbles. Therefore, two replacements are fabricated using the rubber from a bicycle inner tube. They may have to be adjusted later, when it will be the time to put the chassis into the cabinet, but for now, they are okay. The dial panel has been repainted, but the indicator is still as it was before. Instead of painting it, some Teflon tubing is used to make it more visible. The dial glass returns to its place. Now it is possible to verify the correct alignment of the band indicator. Two LED pilot lamps are going to be installed, but this particular type needs some extra insulation. The chassis is now ready for a preliminary test, and with the occasion some labels with the tube designations are attached. The reception test starts with the long wave band, but as already mentioned in a previous section, in this unit the local oscillator starts working only when the variable capacitor is half open, regardless of the adjustment of the trimmer C18. In this unit, traveling the long wave band, it is possible to cross the boundary of the intermediate frequency, which is noticeable from the particular noise reproduced by the loudspeaker. In the upper part of the band, with this unit it is possible to receive stations that are intended to be in the lowest side of the medium wave band. The medium wave band of this unit works normally, but without pretending to be aligned with the dial scale.
تساؤلات واسعة حول ما يتزاد ذلك على المشهد الأمني.
The same normal behavior has the shortwave band. The remaining screws holding the speaker panel to the cabinet are removed, and the panel comes off. The grill cloth seemed intact, but it is not. There is a hole, and it should be replaced. For now it is removed, and that allows access to the screws holding the decorative grill, which needs to be repaired. The decorative grill is removed. For replacing the missing bar in the decorative grill, a squared aluminum pipe of the right size was found. For bending the aluminum pipe, a shape is made using a piece of scrap wood. With the help of a vise, the pipe is bent. The result is carefully checked and precise measurements are taken to cut the bent aluminum pipe exactly to the desired size. The existing decorative piece is cleaned, but in doing so one of the surviving bars comes off, and it can be seen that these pieces were simply soldered together. Before proceeding any further, it is necessary to resolder all the original pieces. On the existing decorative piece, as well as on the new aluminum pipe, two holes are made for inserting two very small self-tapping screws. But these small screws are insufficient for holding the new aluminum bar in place, and also in this case it is necessary to solder it, even though with aluminum this can be difficult. With a small electric hot plate, the ends of the aluminum bar are heated, so that the solder can be melted on top of them while scratching the aluminum surface with a pointed iron tool, allowing the solder to stick properly. All this must be done with great care for avoiding burns. Later, the excesses of solder on the aluminum are removed with the soldering iron. The original decorative piece is prepared with solder as well. The aluminum bar is connected again using the small screws, and then it is also soldered. Finally, the repaired decorative piece is cleaned using a detergent alcohol and a wire brush so that it can be painted. The original varnish of the cabinet is in very bad condition, but it is unclear what it is. In the hypothesis that it could be shellac, some denatured alcohol is applied, but it does not soften the varnish, leaving instead a white haze on it. Only acetone shows to be effective. ChatGPT suggested that this could be an early nitrocellulose lacquer. With a lot of patience, using acetone very carefully, the cabinet is stripped from the old varnish. Eventually, the cabinet is completely stripped, revealing a very beautiful veneer. It is then possible to understand the reason for so much black stain that was used on every corner. It was needed to hide all the wood nails and other possible aesthetic imperfections. There is a corner on the back of the cabinet that has lost the veneer. It is filled with wood filler. Compared to the weight of the chassis, the cabinet is made of relatively thin plywood, kept together with wood nails and glue. Unfortunately, the chassis occupies all the space, and there is not enough clearance for adding wood blocks. The structure of the cabinet seems to be still intact, and only for precaution, some vinyl glue is poured on the corners with the purpose of filling possible invisible gaps, with the hope to provide a little bit of extra strength once cured. This process requires several days. The cabinet is now ready for applying some stain. This is a water-based stain applied using a paintbrush. When the stain is dry, some red oil is also distributed on all surfaces. In the end, some opaque clear acrylic paint is sprayed for protecting the cabinet, but off camera. An attempt is made to print a copy of the Clarson logo on water decal paper. Unfortunately, due to the light color that is supposed to represent the original gold, before printing the yellow a base of white would be needed, otherwise the result becomes invisible on a brown surface, like this clip shows. Without the possibility of pre-printing a white base, the backup plan becomes to use just regular paper, using a brown background color. After the label is glued, the cabinet is sprayed with more clear acrylic paint. The repaired speaker grill is connected to the cabinet. Using the original screws, it would not be possible to use new screws because the thread is not standard nowadays. Some contact adhesive is applied to the surface on which the grill cloth should be attached. The original grill cloth is very dirty and also perforated. A new piece of fabric with a similar pattern is applied in its place. Then the other pieces that are necessary before installing the speaker are mounted, finding the original screw holes using the same original screws. Although that was not part of the original cabinet arrangement, an extra cloth is glued inside for protecting the speaker cone, which is still intact. The exact place of the original holes for the screws that will hold the speaker cone are marked precisely. The speaker is cleaned and then the cardboard used for protecting the cone is removed. The speaker is installed in the cabinet using the same 3 original screws. The band selector shaft is shorter than the others, and for this reason every millimeter counts. The rubber used to hold the dial glass in place is too thick and prevents the chassis from reaching all the way to the front panel of the cabinet. Therefore, it is necessary to reduce the amount of rubber before the chassis can be inserted properly into the cabinet. Then, the chassis is inserted in the cabinet, but before fixing it, the knob for the band selector switch is installed, verifying that it can be operated correctly. New screws are used for fixing the chassis at the bottom of the cabinet together with large washers. Then also the loudspeaker is connected to the chassis. Finally, also the last knobs are installed. The cabinet of this radio model requires a back panel made with a specific shape, resting just above the level of the chassis. Since it was available, a piece of high-pressure laminate was used to make the back panel, which is now installed, completing the reassembly process. The test is done in the evening starting with the long wave band. Unfortunately, the internal oscillator does not work in the lower part of the band, and so the alignment has been done with the aim of also covering the lowest part of the medium wave band. Anyway, on this radio model, the long wave band crosses the boundary of 455 kHz, and when the radio is tuned close to that frequency, a disturbing noise is reproduced by the loudspeaker. Medium wave band.
Yeah, so it's over, man. So it's going great. Good. So it's a big day for mentira. También sacó él y otra persona el tema de Antonio Roca.
Plutonium effective extra unidos están a nivel nacional.
But he might want to bring this squad together and say to this players, look, we had some good times, let's make
la positività di mercati rilascio l'inflazione, faccio segnare di alto delle cose. Estábamos al jefe de cultura de ABP. ¿Qué tal, Jesús? Buenas tardes.
Hola, buenas tardes. Pensé que habéis pasado frío, pero
¿Qué esperéis? Польская области. Военноведомстве Закладе, километр от Славянска, одного из главных центров обороны вооруженных сил Украины в Донбассе, а всего за неделю под...
Shortwave band.
يعني الاسبوع ده كذا حاجه موقف كده حاجات حلوه
Arktik bölgesinde Rusya'nın çıkarlarını göz ardı eden her türlü girişimin geniş çaplı sonuçlar doğuracağını ve bu tür eylemlerden
Itu angin panas.
Kak, amin. Negyedik pont. Szűrtlen felesleges vizet a felhő szülgomváról, de van ez ki. Tizenszeszkel kódolni aszattomni horóhó. Mi a... Na politiki, aki...
We have a strong trading route. But as our trade share
嘅過程中，你嘅身體情況對你呢個愛好造成啲困難咁咧？Další počet běžníků z Číny. Malvoyante venant de l'équipe pleine de coups, les participants s'installent l'un après l'autre devant une table.